Hello and welcome to today's lesson on calculating moments of a force. In this lesson, we will begin by learning the formula for calculating the moment of a force. We will explore the different variables and units involved in this formula. Finally, we will work through various examples to consolidate your knowledge. So far, you have gained an intuitive understanding of the turning effect of a force. You know that an applied force can cause an object to rotate around a pivot point. And you've seen this in everyday situations like opening doors or using seesaws. Building on this understanding, we can now delve into the mathematical relationship between force, distance, and the resulting moment. Let's get started. The moment of a force is calculated using a simple yet crucial formula. The formula is moment equals force times distance. Let's now spend some time understanding the variables and units involved in this equation. The moment measures how much a force causes an object to rotate about a pivot point. It's important to note that the moment isn't just about the amount of force, but also where the force is applied. The moment is measured in Newton meters. Then we have force. This is the push or pull applied to an object, measured in newtons. In our formula, the applied force is a critical factor in determining how much rotational effect it will have. Finally, we have distance. This is the perpendicular distance from the pivot or the point of rotation to the line of action of the force, measured in meters. It's essential that this distance be the perpendicular distance to ensure accurate calculations. Let's apply what we've learned to a few specific problems to consolidate our new knowledge. Imagine you are using a wrench to tighten a bolt. You apply a force of 25 newtons at a point 0.3 meters away from the pivot. What is the moment produced by this force? First, identify the given values. We know the force is 25 newtons and the distance is 0.3 meters. Then plug the values into the formula. So we have m equals 25 times 0.3. This gives us m equals 7.5 newton meters. So the moment produced by using the wrench is 7.5 newton meters. Question 2. Consider a door where you apply a force of 15 newtons perpendicular to the door handle, which is 0.8 meters from the hinge. Calculate the moment produced. First, identify the given values, so we have the force of 15 newtons and distance of 0.8 meters. Then use the formula moment equals force times distance. This gives us m equals 15 times 0.8, which equals 12 newton meters. So the turning effect, or the moment produced when you push the door, is 12 newton meters. Question 3. Imagine two children playing on a seesaw. One child, child A, weighs 30 newtons and sits 2 meters from the pivot. Another child, child B, weighs 40 newtons. How far from the pivot should child B sit to balance the seesaw? First, identify the given values for child A. The force is 30 newtons and the distance is 2 meters. Then calculate the moment produced by child A. So we have m equals 30 times 2. Therefore, the moment is 60 newton meters. To balance the seesaw, the moment produced by child B must be equal to the moment produced by child A. To calculate this, let the distance child B needs to sit from the pivot BD. Using the formula, we can input the known values. So we have 60 newton meters equals 40 newtons times by D. We now need to solve for D. Rearranging the equation gives us D equals 60 divided by 40. Therefore, D equals 1.5 meters. So, child B should sit 1.5 meters from the pivot to balance the seesaw, creating an opposing moment. In today's lesson, we learned about the concept of moments in physics, focusing on the equation moment equals force times distance. We delved into the variables involved and looked at how a moment represents the rotational effect of a force and the importance of using the correct units. A key point was ensuring the distance is perpendicular to get accurate calculations. In summary, understanding how force and distance interact to create rotational effects helps us solve problems involving moments, enhancing our grasp of forces and their applications in real-world scenarios. Watch the rest of the GCSE physics course at Sophos Education.